Okay, I only got like 20 minutes, which is fairly short. I'm going to talk about containers and systemd. Containers, of course, are all the rage these days with Docker and these things. I'll probably focus more on a different kind of container, but yeah. I'll discuss three different topics. First of all, systemd running on the host that runs the containers, then systemd inside of the containers, and finally systemd as the actual container manager. The talk's going to be fairly technical, and I'm sorry for that if people can't follow all the time, but I'm trying to make this understandable for the broader audience. So, the first part is systemd on the host, right? We have a component there in systemd. Just a little bit of background, like systemd is like this we consider the basic set of components that you can build an operating system from. And one of these components is systemd machined. Systemd machined is something where container managers can register their containers with. Like we use the word machine as a more general word for container because we also cover virtual machines. Like VMs, like KVM style, classic CPU virtualization. Yeah, systemd machined does very little actually. It really just keeps tracks of locally running containers. The purpose of that is that it allows integration of the various container functionality into the rest of the system. There's one command line utility for that called machine control, and you can use that to interface with machined. It will show you what containers are running and will allow you to run a couple of commands. So, of course, the question is why have this if the container managers can do that themselves? A little bit of an explanation like what we provide there. It's the machine control terminate, for example, this trivial thing just terminates a container you started. Machine control shell gives you a shell in any container manager started, in any container started. Machine control login does something very similar. It gives you full login prompt. This works with any container manager that you have, like as long as it registers itself as machined. Pretty much all of them do these days, right? Like regardless if you use LXC or at least the Docker version that Fedora or Red Hat provides, they all do that. So these commands work with all of them. nspawn, which is systemd's own minimal container manager, does it too. We'll come to that later. Now, machine control terminate, machine control shell, machine control login all have counterparts with the various container managers, so they themselves are not very interesting. Because they implement something that's available anywhere in these things. But systemd's own commands, journal control, system control, login control, systemd run, and a couple of others, they all have these switches called -m, which allows you to execute the command that you want to execute, not on the host, but actually inside of the specific container. For those who have not experienced systemd that much, I hope most of you actually have. But so journal control is this tool that you can use to query the logs of a service or of the entire system. System control is the main command that you use actually to interface with systemd. It allows you to start and stop services and see what's running. Login control allows you to see who's logged in and on which seats and these kind of things. Systemd run is a command that allows you to run any command line dynamically as a systemd service, right? So that you don't have to have a static service definition, but can do that dynamically at runtime, and then you have the benefit that you can actually do resource management and all the functionalities that systemd offers you for services that it runs right from the command line without having to write a unit file. All these commands have this -m switch, which basically means journal control -m followed by a container name shows you the log of that specific container. Right? System control -m, if you invoke system control start HTTPD, that will run the HTTP server on your host. But if you specify system control start -m, some container name and HTTPD .service, then it will start that HTTPD inside of this container that you specified. All that's necessary for that again is that these container managers register this their containers that are running with machined, and most do. Login control, same thing. It allows you to see who's logged in on a container, which usually is not too interesting because people don't log into containers that much. But systemd run -m is actually one incredibly useful command because it allows you to run arbitrary services. You can put them together on the command line on any system. It can either be the local one like the host or in any container. It can actually be remote systems too, but that's kind of out of focus for this talk. So, and that's really, really useful because, like, if you let's say you have one host running 200 containers or so, by using systemd-run, you specify which container you want to run your command into, and it will do the right thing. Will go into the container, run it in the systemd instance there. This is just to give you an idea about the commands. There are actually many more commands that have this -m logic and allow you to execute certain commands on specific containers. Another thing that Machined provides you is something called NSS my hostname. Sorry, I made a major typo. Actually, it's my machines. Actually, not my hostname. What that is actually, the NSS is the name service switch. It's a libc feature. It allows you to do name resolution. Like it basically is the thing that like the libc API that is the interface to DNS traditionally, right? Like where you specify a host name, gives you the IP address back. But NSS is more generic. It can have sources like this translation sources from quite a few other places. Now, we provide automatic name translation so that if you have a container that has its own IP configuration, simply by running it and having it registered with Machined, the name of that container will be resolved to the IP address of that container without any further configurations. Just that. It's just by having the container registered with systemd. Yeah. To underline that again, works for any container manager registered with it, and that includes LXC and whatever else, and also libvirt LXC and things like that. So much about systemd on the host, right? It's kind of nice. You shouldn't expect too much from it because Machined, it again doesn't really do much except for registration and exposing this information about which containers are running and in which mode they are running to other applications like the ones that I showed you here. This integration goes actually much further than I put in the slides here. Like for example, PS. You know, this classic Unix tool PS that shows you the processes of the system. It actually has integration with that as well, because you can type PS-EO PID, comma, machine or something weird like that, and it will actually show you not only the processes that are running on the system, but also for each process which machine, like in which is again the generic term for container, in which container they're actually running, right? Which is really, really useful because if you think you have 200 containers running on your host, right? And each of these containers has one HTTPD instance. They will appear normally if you just type PS, all under the same name, which is HTTPD, which is not very useful. But if you use that PS-EO PID, comma, machine and things like that, then you will actually see, okay, this is the HTTPD from that container, and that's the HTTPD from the other container, and then you know the details about that. Yeah, that's a lot more integration actually. I don't want to really go into much detail there. Next topic is actually systemd inside the container, right? This is something different. This now means that you have containers, and instead of just running specific services, they run mostly like a system inside of them as well that also runs systemd. This is just to give a little bit of a background with this. What Docker tries to do with containers is something slightly different because they focus on microservices, right? Like for them, microservices are you run one service per container, and if you want to run two services per container, that's kind of the exception for them. They support that in a way too, but mostly you would instead rather run two containers. This is kind of for systemd that use case doesn't really matter too much. What I'm kind of focusing here is if you run systemd in the container, then basically your container is like the host, right? It has a full service manager and can run as many servers as you want. You can use the same tools to maintain the container as you can maintain on the host because it's kind of the same thing. It runs systemd and it's really the same thing. The systemd in the container stuff, it should just work, right? Running systemd as PID1 inside of the container mostly just works as long as the container managers implement a certain number of requirements. Most container managers actually do that. Some don't. Docker is particularly not good at that because they, for some reason, don't like systemd very much. But it's getting better. So, yeah, so it mostly just works, right? You don't have to think about that. And there are quite a few integration points actually where the host and the container interface that are not directly visible to the administrator, but which are good because they exist. Like for example, this starts with very superficial stuff, like a provision of the machine UUID. Like on systemd systems, every system has a UUID, like this random number that identifies or is supposed to identify the instance. With systemd, if you run it in the container, there's actually a way how the container manager can specify the UUID that systemd then uses. That's one thing. Another thing is, sounds a little bit boring, is actually starting a login prompt. Because a container is actually quite different than a physical machine. Because in a physical machine you have VGA and like a frame buffer and a real TTY and things like that, where you can show the login prompt. A container works quite differently. You only have pseudo TTYs and things like that. So if systemd, when it runs in container and the container manager is nicely set up for that, it will just do the right thing and start login prompt instead on the trying to do that on the physical VGA. We'll just do that on the pseudo TTY or multiple if that's configured. There's support for socket activation. I'm not sure if you guys know what socket activation is. It's basically a concept that systemd is very strong on, which allows that systemd listens on a socket, like a network socket, and starts a service only when a connection comes in, right? Systemd inside of the container has been prepared so that it can actually do socket activation of the containers, so that it is systemd on the host that listens on a TCP port when a connection comes in. This TCP socket can be passed to the container manager. The container manager can then pass it to the systemd instance inside the container, and the systemd instance inside of the container can then pass it on to the actual service activated, like the HTTP running inside of that. So you actually have the full chain of that. It can be like 10 levels up where the actual listening on a TCP socket happen, and it can be passed through from the host to the container. This is, by the way, some functionality that is only doable with containers, right? It's not doable with VMs or anything like that, because the container, like the file descriptor concept, like the socket concept, is something that is transparent to containers or can be passed around only through containers, but not through VMs. So this is actually really useful functionality, because it basically allows you to drive up the density of your server deployments quite a bit, because you can basically say, yeah, I have the servers, and this server runs like 50,000 actual TCP ports or something, but it actually will not run the services for them all the time. It will only run them when they're activated. So yeah, something else is systemd by default, when it detects that it's running in a container and the container has been set up the right way, it will actually do the right thing and configure the network of the container correctly. Like it will effectively do DHCP plus a couple of other things. So basically, if you have a systemd payload that you run inside of your container, and the container manager makes sure that he creates the right VTH link, like virtual Ethernet link, to the host, then nothing has to be done. The networking will just work because systemd does it out of the box. There are quite a few other integration points. This is just to give you an idea how, like at which level, like a more superficial level, or these kind of things where running systemd inside of a container can actually give you quite a benefit, because you get this kind of integration. There's also like what I didn't put on the slides here is like a lot of stateless support, right? So like there's this concept that you can run containers where you have one container, and the first time a connection is made to that container, a new instance of that container is duplicated from the original image, and then from that point they basically can diverge. But so that this instantiation of the actual containers on disk actually has to happen only when the connection comes in. And this is something we call stateless logic, because it basically means that you deploy a single /user tree and deploy it many times, like you copy it basically in etc and var get initialized dynamically. Now I'm running here through the different topics with the stateless stuff, and it's completely okay if you don't follow what I'm saying here. It probably is a talk of its own talking about the stateless stuff, which is the reason actually why I didn't put it on the slides in the first place. So I want to talk about the third topic, which is systemd-nspawn as the container manager, right? Like the first two parts that we talked about is like first running systemd on the host and describing the integration points that it provides for container managers that run on that host. The second thing that we talked about was running systemd inside of the containers. And now the third one is running systemd as the container manager, right? Like it's a third part. So systemd comes with a small container manager. It's called nspawn. It's supposed to be minimal. The background why we wrote it is actually not that we wanted to get into a competition with Docker and these kind of things, but mostly because we were developing systemd, which is an init system, right? And if you develop an init system, you basically have to boot up your machine all the time, because that's how you have to test it, right? And we didn't want to reboot our systems all the time just because we changed some code somewhere and we wanted to test it. So we decided, okay, let's run that in Container Manager, because the container, starting that is really, really fast. Now, back at the time, the container managers weren't really that useful, and so we decided to just do a minimal one of our own, which is systemd-nspawn. Systemd-nspawn, it's really trivial, right? The idea is basically that you just point a directory where you have an operating system installed, right? Which is like the full hierarchy consisting of etc and var and user and these kind of things. And you point nspawn to it and we'll boot it up virtually on your system, and then you can shut it down. So that's how systemd-nspawn got started and what it is now. It is built in with systemd. It just comes with systemd. If you have systemd, you have that. Because, I mean, again, this thing is really tiny, really. All it does, it sets up a couple of namespace things and runs a process in a very special way. It's like a cheroot on steroids. Like, I think most people of you who have used Linux came into contact with cheroots sooner or later. And nspawn really is just that in a little bit more special way. Now, nspawn is kind of nice. You can do like a machine control, like the command that I talked about earlier actually has commands that actually interface directly with nspawn, so that they are not generic. This is machine control start and machine control enable. To say this explicitly, the focus with nspawn originally was just for testing our own stuff. But people actually started using of that, and it's now used in production by many people. So our focus number one with nspawn is really about OS containers, right? Containers that carry a full OS, meaning that there's a systemd running inside of it that does the full service management and things like that. So it's different from Docker, like I mentioned that earlier already. The other focus is nspawn is supposed to be minimal, right? It will not, it doesn't cover everything that LXC covers or something, or OpenVZ or whatever else there is. It tries to be really just a basic building block that other people can build from whatever they want. And people do. Like there's CoreOS Rocket, if you've heard of that. CoreOS has developed its own container manager that tries to do microservices, right? Is basically in direct competition with Docker. And it's called Rocket, like RKT, just they had some trademark things, so they had to remove the O and the C and stuff like that. So this Rocket thing basically is written in Go, but it does everything that Docker does with building images and downloading images and things like that. But at its core, for the actual container execution, it uses nspawn, like this tiny integrated thing of systemd that's already there instead of developing itself. Now, this talk, of course, needs to be quick, so this is kind of the last slide I want to show. It's a basic mode of operation of nspawn. If you actually want to use it as an administrator yourself. It's actually a really useful tool. Like if you're an administrator, have a look at nspawn, because it will do a lot of things, because it's a cheroot on steroids. So the basic mode of operation is you place an OS tree in var lib machines foo, right? The OS tree really means just putting in another operating system there, like so that you have var lib machines foo etc, var lib machines foo user, var lib machines foo home, and so on, like you know it from Linux. Then you can test it by simply invoking it. Test it with systemd-nspawn-m foo, right? And then it will actually, if you run that, and if I had time, I would actually show that here. You will just get the boot logs, and then you get your login prompt. You can log in here inside of that container. And if you're happy, you can enable it permanently by doing machine control enable foo, right? Which basically says, now enable this so that at next boot it's started automatically. This is really the basic mode of operation. To make this easier for you, you can actually use this thing. I had to make the font smaller because the URL is so long, but it actually didn't work. It's still too long, so I put the ... in the middle. But basically there's this command machine control pull raw, which actually allows you to download any disk image you can find on the internet and put it into that directory. This is, for example, an example how you do that with the Fedora disk image that they provide for the cloud stuff. And if you do that, then the next thing is you can invoke it directly. It's really as simple as that, right? Like if you want to see what Fedora Cloud Base currently is like, you just have to find that image. You find it on the Fedora images, and you can Fedora FTP server, and you can just run it like that, and it will just work. It also works for Ubuntu images, by the way. What really matters is that the image that you download is somewhat recent, so that it, for example, runs systemd inside of it, or upstart will work too, but it's kind of happy to work in a containerized environment. And I think my time's already over. How much time do I have? 2 minutes still. I don't want to take too many questions, but we can have fill the last 2 minutes here with questions. But I'm going to do another talk in a 1 hour session on Sunday, where it's just about talking about systemd. So if you have any questions about this or any other talking about systemd, let's talk in detail more there. I'm open for anything like this stuff or anything else. Anyway, let's fill the 2 minutes with questions. So anybody has questions? I hope I was not too fast. I know I was very fast. Sorry for that. No questions. There's a question.
So you say systemd runs a process inside a namespace of a container. Can you also inject binaries into?
Yeah, machine control actually has something where you can copy files in and out of a container, and it works. It actually will not work for Docker yet, but it works for nspawn containers at least. Any other question?
Well, is there any way to authenticate the image in that specific?
It actually, yeah, it does that, but it doesn't do that for Fedora. But it tries to download the SHA-SUM file, and will actually do GPG verification if it's signed. And the irony of that is, even though I work for Red Hat and Fedora, all of that works fine for Ubuntu because they actually put the SHA signatures and the GPG stuff under fixed names. The Fedora people are incapable of doing that. They pick random names for every time they drop those files there. Because we don't know them, we cannot do that. So basically, yeah, you get verification if you download Ubuntu images like this. You do not get verification if or you actually have to turn it off explicitly. By the way, if you're looking for that, how that looks like the command line that you can use there, go to the man page of machine control. At the end, it actually shows it exactly how to do that.
One more question. One more question.
Okay, one more question.
So what's coming up next?
Well, the other talk I had kind of was going a little bit talking about that. Like the last slide was mostly about that, and a couple of other the things that we did. Like, yeah, the other one didn't have video, I think, or did it? I don't know. But it's a lot of stuff, of course. But yeah, let's talk on Sunday. I think that was my last question, right?
Yes.
So thank you very much. See you on Sunday, of course, and I hope this was useful, even though it was quick.